Hello everyone, in this video let's discuss about the 1-bit comparator circuit, or you can call them as the magnitude comparator. Magnitude comparator. So what this circuit will do is, it will compare between the inputs. So first let's write the block diagram of the 1-bit comparator circuit. So we all know that in the block diagram we are going to just represent what are the inputs and what are the outputs. So since we are taking 1-bit comparator, we will be having two inputs. So let me call them as A and B. So you can take any variables for the inputs representation. So this is the block and this is 1-bit comparator circuit. So in this 1-bit comparator circuit, since I am having two inputs, so my outputs will be of 3. So one will be greater, another one will be less, and another one will be equal. It is like A equal to B, A less than B, A greater than B, like that. So we will be comparing between the inputs. Now let's write the truth table for the given inputs and the outputs. So in the truth table, what we will be doing, we will be writing the all the possible conditions of inputs and the outputs that we are gonna get in this circuit. In the input side, we are having A and B as the inputs, and in the outputs, we are having greater, less, and equal. Now, since I am having only two inputs, what will be the possible combinations of the inputs? 0, 0, 0, 1, 1, 0, and 1, 1. Now if you see here, 0 equal to 0, that is A equal to B. So equal, these two will be getting 0. 0 and 1, A is less than B, so less than B. A value is 1, B value is 0. A is greater than B. A value and B value, both values are equal to 1. So A and B are equal to each other. Now using this truth table, we will be writing the equations for the outputs. That is the characteristic equation for the outputs. So what are my outputs? Greater, lesser and equal. Greater, lesser and equal. So here in this greater, A is greater than B, like that. E less than means A less than B, and in equal, A equal to B, like this. You just represent them. Now let's write the equation for the greater. So if you see the truth table's output side, and where and all the greater value will be equal to 1, you must choose that one. So if you see here, when greater value will be equal to 1, the inputs are A value is 1 and B value is 0. A value is 1 and B value is 0. So I am putting B bar because B value will be equal to 0 here. So now let's write for lesser. So only one condition where A value is 0 and B value is 1. A value is 0, so I will be using the bar, and B value is 1. Now let's write for equal. Equal is having two conditions. A value is equal to 0, B value is equal to 0. A value is equal to 1 and B value is equal to 1. So you can write A bar B bar plus AB. So you can also represent this one using the A x nor B. A x nor B, like this. A x or B. This is A x or B. You must use A x nor B. That is bar, not get. A x nor B, like this also you can represent. Now let's write the logic diagram for the outputs. So I am having A and B. So I will be taking A and B itself. Here I will take A and here I will take B. We are having bar also, that is A bar, B bar, like that. So I will be using NOT gate in between them, that is A bar. So this will represent B bar. First I will draw for the greater one, that is A, B bar. A and B bar. In between them dot is there. Nothing is there means multiplication. So multiplication means we will use the AND gates. So this is greater. Next let's write for less. A bar B. So A bar and B with the AND gate, it will be for lesser. Now let's write for equal. A x nor B. So you can represent like this also, or you can represent simply like this. So let's represent simply like this itself. A bar B bar. So A bar B bar in the AND gate, and AB, A and B with the AND gate But if you see here, in between them plus is there. So what I will be doing, plus means it will be of the OR gate. So this is of the output equal. So in this video, we represented the block diagram, truth table, characteristic equation of the outputs and the logic circuit diagram for the 1 bit or the magnitude comparator circuit. If you have any doubt regarding this topic, please do comment below, and the full playlist link of the digital logic design is given in description. You can access it. Thank you.